Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact, straight from the leaders making it happen. Today, a C-level playbook for sustainable AI. Why measure carbon? How to reduce it without breaking models, and how to turn efficiency into business value. This episode is for CEOs, CTOs, CDOs, and senior ML leaders who need defensible operational approaches, not slogans. Quick preview. We'll define the metrics that matter: kWh, CO2e per training run or per inference, amortized infrastructure emissions, map instrumentation across the ML lifecycle, and give a step-by-step baseline measurement plan. We'll cover real trade-offs, when to retrain versus prune or distill, and executive controls for procurement, budgeting, and KPIs. By the end, you'll have 2 immediate actions to start in the next 12 to 24 months. I'll reference insights from a chief data officer at a large retail and logistics company who led a multi-year sustainability program across training platforms and inference fleets. That person wishes to remain unnamed here, but their practical examples will shape the playbook. Let's get started. Background context. The guest's team operated hundreds of models, catalog recommendations, demand forecasting, real-time fraud detection, across multiple clouds and private data centers. They saw concrete cost savings when measuring energy use and avoided regulatory exposure by bringing carbon into model governance. Their approach was measurement first. Baseline, instrument, iterate. That's important because sustainability without measurement is just opinion. Let's jump into metrics. The minimal set every executive must understand. Kilowatt hours consumed, CO2e attributable to that energy, and normalization units that make models comparable. 2 practical normalization choices: per inference, useful for production services, and per training run or per epoch, useful for R&D and model selection. You also need amortized infrastructure emissions, that is, share of on-prem racks or GPU fleet assigned to model development and serving over a defined period. Concretely, track kilowatt hours at the job level for training runs. Cloud providers expose energy or carbon estimates in billing APIs or carbon dashboards. When they don't, estimate kilowatt hours from instance type, runtime, average CPU/GPU utilization, and published power draw. Convert kilowatt hours to CO2e using regional grid emission factors. These vary by geography and hour of day. And for private data centers, use measured PUE and facility emission factors. Instrumentation points across the ML lifecycle. First, CI/CD and experiment runs. Attach energy logging to your training jobs and notebooks. Second, model registry entries should include carbon and energy metadata per model version. Third, inference telemetry must capture usage counts, average latency, batch size, and compute resources used per request. Fourth, the deployment layer needs to report instance hours and utilization so you can map back to per inference estimates. Tie all of that into a centralized dashboard for executive reporting. A simple step-by-step baseline plan executives can mandate. 1. Select your top 20 models by spend or business impact. 2. For each, measure a 30 to 90-day baseline of training and inference kWh and CO2e. 3. Normalize per business unit and per model work unit, e.g. CO2e per order predicted or per dollar of revenue impacted. 4. Publish an audit-ready baseline in your governance repository. 5. Set targets and guardrails tied to that baseline. This is how sustainability becomes measurable and actionable, not aspirational. In our program, the first 90 days exposed surprising wins. One recommendation model had large batch jobs running nightly that could be incrementalized. Small code changes cut training time by 60%, which reduced kilowatt hours dramatically and lowered costs. Measurement revealed low-hanging fruit we wouldn't have found otherwise. Now, the trade-offs. Efficiency often competes with accuracy and latency. The 3 levers: model architecture, distillation, pruning, quantization, runtime, batching, caching, instance selection, and process, retrain cadence, dataset sampling. Decision framework, quantify the performance delta, cost delta, and carbon delta, then score against business SLAs. If a 0.2% accuracy loss reduces CO2e by 40% and cost by 30% with no user-facing impact, that's often a net win. But if model performance directly ties to revenue or safety, you prioritize accuracy and invest in other efficiency levers instead. Examples to consider: distillation to smaller models for edge or high-throughput inference, using mixed precision and quantized kernels for GPU inference, asynchronous batch scoring for low-latency insensitive tasks, and reducing retrain cadence when data drift isn't material. Always validate with A/B tests to ensure any efficiency change doesn't erode business KPIs.
Infrastructure choices matter. Region selection can change CO2e per kilowatt hour dramatically. Some regions have cleaner grids. Scheduling non-urgent training in those regions or during low-carbon hours can cut carbon footprint without changing models. Use spot or preemptible instances for non-critical workloads to save cost and energy, but add resilient orchestration and checkpointing. For on-prem versus cloud, ensure you amortize the facility emissions correctly. Ignoring data center PUE and cooling skews your measurement.
We negotiated procurement clauses with cloud vendors that required carbon reporting by project and hourly region-level emissions data. That enabled us to schedule heavy training to periods and regions with lower grid carbon intensity. Procurement language is a lever executives can use to make vendor behavior visible and accountable. Leadership and governance. Sustainability belongs in the model approval workflow. Add carbon and energy fields to model cards. Require a cost-carbon performance trade-off statement for each major model release, and include a sustainability sign-off in senior oversight committees. Tie sustainability targets into budgeting. Show how efficiency translates to OpEx savings or deferred hardware purchases. Align procurement incentives so teams choose cleaner regions, efficient instance types, and cloud providers that publish transparent carbon metrics.
Measuring ROI. 3 buckets: direct cost savings from lower compute, risk reduction, regulatory compliance and disclosure readiness, and brand trust value. Quantify each: OpEx saved per year from efficiency changes, estimated fines or compliance costs avoided, and qualitative brand impact tied to stakeholder expectations. Present these together so boards see sustainability as risk-adjusted value creation, not just cost.
Culture and incentives matter. Encourage engineers and data scientists to optimize for energy alongside latency and accuracy. Celebrate efficiency wins publicly inside the company. Create quarterly targets and a leaderboard for model carbon intensity. But be wary of greenwashing. Require audit-ready baselines and versioned reporting so any public claim is defensible.
Looking forward, hardware specialization will continue. More efficient accelerators, better mixed precision support, and more transparent provider metrics. Regulatory scrutiny will grow. Expect reporting requirements for material carbon footprints and disclosures in many jurisdictions. Leaders should prepare by making measurement and governance first class, not an afterthought. 2 practical actions for the next 12 to 24 months you can implement today. Action 1. Mandate baseline measurement for your top 20 models within 90 days. Collect KWH, CO2e, per inference and per training metrics, and publish a versioned baseline. Action 2. Add a carbon performance cost statement to your model approval gate and update procurement contracts to require vendor carbon reporting at project granularity. Those 2 moves unlock visibility and governance immediately. Final reflection from our team. Measurement drove the most meaningful choices. Once you have data, conversations change from ideological to empirical, and you can make trade-offs that protect business outcomes while materially reducing environmental impact. That's the difference between models and value. If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.